This video is on trigonometry and angles of 30, 45 and 60 and how to work with them without a calculator. So I'm going to start by drawing some triangles here, and you're going to need to remember how to draw these triangles. So the first triangle is going to look like this. So we're going to have a right angle triangle, and I'm going to say that this length is 1 and this length is 1 and the right angle is here. So if the right angle is there and two of the sides are the same, that means this is an isosceles triangle. So this angle and this angle must be the same, and that makes these two 45 because that's 90. So I can say that this angle is 45, and I can say that this angle is also 45. Now I can find the length of the hypotenuse as well using Pythagoras theorem, and to do that I need to do 1 squared plus 1 squared and square root of that. So that's going to be 1 squared plus 1 squared and square root of that. So 1 squared is 1 plus 1 squared is 1, so that's square root of 2, square root of 2. So this length here is square root of 2. Now we're not finished here actually. We've got a right angle triangle and we've got angles and we've got adjacent sides, opposite sides and hypotenuse. So we can say some things about sine 45, cos 45 and also tan 45. So let's try and find what sine 45 is using this triangle. So sine 45 is opposite divided by the hypotenuse. So that's going to be 1 over root 2. So sine 45 is 1 over root 2. Sine 45 is equal to 1 over root 2. Now also I can see that cos 45, which is adjacent over hypotenuse, is also going to be 1 over root 2. So I can say that this is also equal to cos 45. Now I can find the tan 45 as well. Tan 45 is opposite over adjacent, so that's 1 divided by 1. That's just 1. So tan 45 is equal to 1. So we've worked out these sine 45, cos 45 and tan 45, okay, in exact form, okay, and we're not using a calculator. So this is something that we need to be able to do. Now the next triangle is going to be an equilateral triangle. Now I'm going to label these sides 2, 2 and 2, and you'll see why I do that. But if you can't remember and you put 1 there, it's not a problem, okay? You can still work it out correctly, but it just gives you a bit more work to do. So we have an equilateral triangle here. So I know I got angle of 60 there, angle of 60 there, and angle of 60 there. But what I'm going to do is I want a right angle. So I'm going to bisect this angle and bisect this line as well. And this is going to make a right angle here and a right angle there. So let's do that. So this would make a right angle here. Now I know that this length and this length, but each of these are 1. So 1 there and it's 1 there. And this is the reason why we chose 2 here. If I had chosen 1 there, 1 there and 1 there, then this would have been a half and this would have been a half, and it gives me a bit more work to do. So this is why we chose 2. So now I'm going to change this side to a 1 there. Now we'll just work with this side because this is just the same triangle, just a different orientation. So I know that this angle here is going to be 60 because this was in my original equilateral triangle, and because I bisected this angle, this has to be 30. So let's say that this is 60 and this is 30. Now again I've got one length missing. Now I can find this length using Pythagoras theorem. So it'll be, this is the hypotenuse, so it'll be 2 squared take away 1 squared and square root of that. So I'm going to have square root of 2 squared take away 1 squared. 2 squared is 4, take away 1 squared is 1, so 4 take away 1 is 3, so I have square root of 3. So this length here is square root of 3. Now again, we've got a right angle triangle like we had here, so we can look at sine, cos and tan of 60 and 30 this time. Last time we only had 45, this time we have 60 and 30. So let's start with sine 60. So sine 60, so that will be the opposite over hypotenuse. So sine 60 I can see is root 3 over 2. So sine 60 is equal to square root of 3 over 2. Now also I can see that cos 30 is going to be the same thing because cos 30 is adjacent over hypotenuse. So cos 30 is root 3 over 2 as well. So this is the same as cos 30. Now let's work out cos of 60. So from 60 I've got adjacent over hypotenuse. So cos of 60 is actually 1 over 2, which is a half. So cos of 60 is equal to 1 over 2, which is a half. And I can also see that sine of 30, which is opposite over hypotenuse, is also a half. So that's equal to sine of 30. Now I can find tan of 60 and tan of 30. So tan of 60 is root 3 over 1, opposite over adjacent. So tan 60 is equal to root 3 over 1, which is just root 3. And tan 30 is 1 divided by root 3. So tan 30 is equal to 1 over root 3. Okay, so we've found some values for sine 60, cos 30, cos 60, sine 30, and a few more in exact form. We've got a half here, we've got a 1 here, which does help quite a lot. Now, when we're working with triangles, and we're not allowed to use a calculator, so right angle triangles, we're not allowed to use calculator, and we need to use trigonometry. Now, if it's an angle of 45, 60, or 30 that we're going to use, we can actually substitute this value here for sine 60 and cos 30. So if I'm working with sine 60, I know that that's going to be root 3 over 2. If I'm working with tan 60, I know that's going to be root 3. If I'm working with sine 45, I know that's going to be 1 over root 2, and I can substitute that instead of sine 45. So let's see how that works in an example. So I have a question here. I need to find x, and I need to find x and give your answer in exact form, okay? So I have a right angle triangle here, and I can see that this angle is 60, and I have the opposite side of this angle, and I have the hypotenuse. So this is going to be using sine. So sine 60 is equal to 10 over x. So let's start writing that. So sine 60 is equal to 10 over x. Now, when we were allowed to use a calculator, we would have used a calculator at some point here. But here, because I know sine 60 in exact form, I can just substitute that. So sine 60, if I go up, sine 60 is here, and that's equal to root 3 over 2. So I'm going to substitute that. So root 3 over 2 here. So, sorry. Root 3 over 2 is equal to 10 over x. So I've made a substitution. Now I can just rearrange this and find what x is equal to. So if I multiply both sides by x, I'm going to get x times root 3 over 2 is equal to 10. Now if I multiply both sides by 2, and I'm just going to move here, my working out over there, so multiply both sides by 2, I'm going to get x root 3 is equal to 20. Now, if I want to find x, I would divide both sides by root 3. So if I do x is equal to 20 over root 3, and then that's x. So I've found that x is equal to 20 over root 3. Sometimes the question might say rationalize your denominator, so we'll just do that as well. If I multiply the top and bottom by root 3, so root times by root 3 there, times by root 3 there, and that's going to give me, this is equal to 20 root 3 over 3. So I'll just write that again. X is equal to 20 root 3 over 3. Now, the main thing that we done is we used a substitution for sine 60. Okay, and we get that from these triangles here. So we've got these triangles. This is what you need to remember. So you either need to remember these values here, so these values here and these values here, or if you remember how to construct these triangles and then work out the values from there, I think that's a little bit easier to do. So remember how to construct these triangles and then find your values and then use a substitution in a question similar to this. So we substituted root 3 over 2 for sine 60 here. So if it was a different question, maybe you would choose a different thing to substitute. Maybe if we were working with cos 60, we would be substituting a half, and that's what we would use. Now, here are some questions for you to do. Okay, so you're going to have to use these similar methods. Okay, so answer these questions and then bring that to the lesson.